Hello guys, welcome to another study vlog of mine. Today we are going to solve today's lead code question. So they are given us a question on validating the binary tree. So based on the nodes. So as we know, binary tree is a tree structure which contains parent to child link such that the leaves which we call as terminal nodes, so they won't have any children, and other nodes will have children. So in this case 2 is having children, and 3 is a leaf node, and 1 is a leaf node. So we have solved many things like height of the tree and traversing through the tree, and the type of arrangement of the trees. So now they have given us a normal kind of question where they have asked us like to check whether the whole structure is following a tree pattern or not. So what they are given as an integer n, and the left child and right child arrays. So the 4 indicates the total number of nodes, and the left child of 0, which is the which indicates the left child of the node 0. And if there is no left child, then in the case it will return -1. Okay, so -1 in the sense there is no left child. So the same goes to the right side also. If there is no child on the right side, it will return -1. So they have asked us to traverse through all the nodes and check whether they are following a binary tree structure or not. So if you see this question, it is not following the binary tree structure because a node is having multiple parents. So multiple parents is not a proper way of representing a binary tree. So what we have to do right now, so we have to check whether a node is having multiple parents or not, as well as the structure is properly arranged or not. So I think it is mostly a depth first search pattern. So I think we can solve it. So what I am trying to do is I am trying to use another function validate, and I will check for this node first. If it is following the tree structure, then I will move to its parent and check both the structure, and later I will move to the root and check everything. So it's like a reverse looping, so bottom to top approach. So let's solve it. I think mostly we'll use recursion. So let's go. So as we know, the main motive is to check if the array the given is forming a tree or not. So in order to do that, we need to check the tree properties, which are like a parent node should have only 2 child nodes, not more than that, and parent node should always be independent of the child nodes. That means the parent node should not have dependency with the child node. Only child node should have dependency with the parent node. So the movement should be from top to bottom only, not bottom to top. And child nodes should not have more than 2 parents, more than 1 parent. Child node should not have more than 1 parent, and the root node should not have any parent. Only root node should not have any parent. Rest of all the nodes should have parents. Okay, so in that way I have tried to use the recursion, where I go into the root node. Earlier I thought to take 0 only, because the test cases they have shown us only 0 is the parent node in that. That's why by default I have taken the root node might be 0 only. That's why I have started my recursion from 0, and I have so what I have done is I have used a hash map. So whenever I reach to a node, for suppose in the case 0, if it is reached and if I am looking for its childs, that means I have visited it. That's why I have added it into a hash map, and I have noted it as visited. Okay, so that means true, boolean is goes true. And then I move into the child nodes, and if the left child is not -1, then I go into left child, and if right and add the recursion return type, and if the right child also is not -1, then I'll move into the right side, and I get the boolean values of both those child recursive functions. Okay, and if any one of them is not following the tree property, that means the whole tree is not following the tree property. That means what I'm doing is I'm going from top to bottom, and if any of the bottom structure, bottom subtree structure is not following the tree rules, the whole tree is not following the tree rule. Okay, so top to bottom, doing this will take a time complexity of 2 power h, where h is equals to the height of the tree, right? But then I came to know that there is a mistake, because we should not consider 0 is only the root. We have to find it out, because one test case I have seen, after running my code, it successfully ran, and one test case I have seen where the 0 is not the root node, only 2 is the root node. Okay, so now I understood I need to change my code. So first I need to find which is the root node. Okay, so for this, what I have done, by before running this recursive function, I have traversed through all the nodes, okay, before itself, and I have checked if there is any node which doesn't have any parent. Okay, so that means what I'm going to do, I'm going to take all the children, okay, all the child nodes of all indexes, and if there is a node which doesn't have any which is not there in that hash map of the child nodes, that should be root, right? But unfortunately, I have also seen that there are multiple such nodes. It should not happen, right? Only a tree node should have only one root. But how to solve this problem? That is a big issue for me. And also I have seen, so what I have tried to do is, like, I am unable to understand that logic. So what I have done, I have substituted that value and tried to return, if to bypass that test case, to check if there are any other logics also that we need to implement. Then I have seen another test case where 0 is a parent for 1, and 1 is the parent of 0. That is forming a loop which should not happen. So in order to check that loop, what I have done is, like, if the hash map at the parent node, if I have checked for the child nodes, and if that parent node is already visited and the child node is having a dependency with the parent node, then I can understand. So for checking that also, hash map is only used, right? So the same hash map, I have added just another logic, that is, like, if it is already visited, why you are again visiting it? That should not happen. Then I should return false. So in that logic I have added. But then after, in order to bypass the main one, where I am getting multiple trees, actually not nodes, multiple trees, that should not happen. They have given only one tree array, right? So that means they should not have two different graphs. Only one graph should be there. That should be unified. So for this, it took me a lot of time to solve this thing, because ultimately the node which has no parent should not be more than one. Then I understood why I am searching for, like, all the nodes and checking if it has parent or not. Ultimately, my logic, when I am searching for all child nodes, then only one node should not be there in that list, which should be the root node. So I have not used any logic. After that, I have removed all the bypassing test cases. Like, I have literally substituted the values and got the answer for specific test cases to make them solve, because there are only 44 test cases and mine was 42 test cases passed. Then this is an important approach to, like, substitute your test case values to get a proper output, because you will understand what is the logic, because the test cases they give in the exam, there are only 3 test cases, right? So it's not easy for everyone to, like, directly get into the approach, because after looking only at the 3 codes, I thought there are only, like, 0 is the root, but afterwards I have seen more than 0, and I have seen, like, closed loop test cases also. So then I understood, if a root node is more than 1, then it should not be it should return false. So what I have done, a final hash of the child nodes which I got, if the size of the hash node is greater than it is equals to n-1, then it should return true, else it should be false. So that means the hash map size of the, like the all the child nodes, the length of the child nodes, which should be is equals to n minus 1, and only one node should be parent, which should not be in there in the hash, and that node should be the root node. So if this happens, then I should return true. So I have used this logic, and I have also used the closed loop logic, where the left child of the left child, if it is equals to the parent node, then it is a closed loop. And similarly, if the left child of the right child is equals to the parent node, then also it is a closed loop. So those things also I have used, and I have returned them false. Then I got my answer finally.